Morning, students. It is my pleasure to introduce you our own alumni from 2011 batch, Mr. Naveen Chagganti and Nishant Kaku. Let me introduce their profile to you. Naveen Chagganti, sir, is a senior machine learning engineer and he is currently working for Adobe's applied machine learning team with more than 7 years of experience. He is having an experience in big data, data science, data warehouse, and he had completed his master focused in computer engineering from US. Mr. Nishant Kaku is also our alumna and a wonderful singer, I must note it here. He is a 2011 batch pass out again. He's having an experience as an application engineering with Jain System Mumbai, then 2.5 years experience of project engineering in Mechatronics Engineering Private Limited, and again 2.5 years of experience in embedded software engineering with a Global Edge software. Now he is presently working for last 4 years as a technical specialist with a robot Bosch engineering and business solution in Bangalore, working on radar sensor based on the Advanced Driver Assistance System, that is ADAS, for passenger vehicle. Thank you both of you for joining here for the today's session. I'm sure your experience in the related topics will definitely going to help our students to grow and to choose the correct career path. Okay, so over to you, Naveen and Nishant.
Cool. I'm sharing my screen now. That's okay.
Yeah,
Uh, Let me know if you guys can see it.
it's visible. It's visible.
Awesome. So hey everyone, thank you, ma'am, for giving us an opportunity to speak at least back to for my college. I've been giving talk here and there, but finally I got a chance here, so it's thanks a lot. But when I was doing it, I wanted to like when the team approached me, she wanted me to talk about a bit of mechatronics and instrumentation. So I thought, who are the like my best friend Nishant Kaku is actually a pretty good, very good embedded system engineer for Robert Bosch. He can also give you a better uh, insights on, I would say, the hardware side or the IoT side of it. So the way I'm going to structure this talk today is basically it's going to be a very light talk, honestly. I would actually want this to be more of a conversation than a talk. So we're just going to brush up upon you guys, mechatronics, a bit of the syllabus, focus on a few topics there, and talk about a bit of our experience, our journeys from instrumentations to different fields. And maybe that can help you to get an insight of, how things work outside, or, how what you read in the college, how that can be useful in choosing a career or pursuing a career. So that's how I'm going to frame this session. Uh, I'm going to let Nishant Kaku actually start the session with his experience and his insight of embedded systems engineering. So it's all you, Kaku. Nishant, go ahead. Are you on mute?
Nishant, you are on a mute.
Yeah, yeah, yeah. Sorry. Yeah, thanks, Naveen. Yeah, first of all, thanks, Deepti ma'am, for having me here. It's really, proud moment, I would say, to come back to the this college and just share my journey. Definitely, this will help to the students. So, yeah, I would first like to start with uh, as our topic today is mechatronics. So, would like to for instrumentation, would like to first come to the point like what is the importance of instrumentation in in our regular day or you can say industry. So most of you have already passed went through the transducers and measurement systems and these kind of topics in your curriculum. So these topics actually provides you the better understanding of any system. It can be your mobile phone, it can be your any washing machine, it can be a complex missile system. So any system if you can take that will that how those system works, that knowledge actually you can get it from like from our instrumentation curriculum. There is no other, I would say, source where you can actually try to understand the each small component of any system. So that was like my personal experience throughout my journey. And yeah, so that's why I think it is really important to have instrumentation into the place. The next point we have like embedded system. As I mentioned, few of the names of the application, those involve a lot of embedded system applications in our day-to-day life. So, which you are already getting the knowledge in your curriculum, like microcontroller and microprocessor based subjects which we have in our curriculum. So these are the again small building blocks of the trending technology. You might be worried about like why this trending technology things are not involved in our syllabus, but trust me, these basic without these basic blocks you cannot build the latest technology trends. You should know the basics, and then it will become easier to build on the new technology. About the mechatronics subjects, so I went through the syllabus, and it is pretty good. Like there are if you see there are topics involved like modeling and simulation of physical systems. So the this topic actually gives you a virtual feeling of how things works. For example, you can say any car simulation. So as I know, I have been working with automotive industries on since last 6 years. You cannot go every time on a car and see the performance of your work. That is not always feasible. You have to have a software or some kind of virtual simulation where you see like when you press a brake or when you press accelerator or clutch or anything like start stop button, how the system is responding. That you can check on the software level itself by modeling the entire car in the any kind of simulation platform. So mechatronics gives you that understanding that how the system works when it is simulated, and how to interface that actual car with the software level technologies. So this will definitely help you not only automotive. I just give one example, but it will take you to any industry. It can be healthcare, or it can be aerospace, or it can be your oil and gas industry. It can be anything. So it also has a one more topic of sensors and actuators. So these knowledge actually gives you for a particular application what kind of sensors are must and what kind of actuators should be used, because there are plenty of options are available in the industry. But here in instrumentation, or I would say in the mechatronics also, you will try to you will get the knowledge of how to choose particular sensor or actuator for a particular application. That knowledge comes only when you have learned the instrumentation. Without that it will not come. You will get the knowledge of many programming languages outside instrumentation, but the system knowledge and domain knowledge, which is very much important in the industry, which not everybody has, that usually comes from the experience. But we are glad that we have the instrumentation place in our syllabus, where each system is described very much widely, and the essence of knowing the basic key factors of any systems are already present in our syllabus. So that way I feel like the instrumentation is really important. And also the going more detail into the mechatronics and embedded will definitely take you to the latest technology trends that will actually increase your interest, that will make you inquisitive for particular topic. So you should go after it. Yeah, Naveen, we can go to the next slide. So yeah, this was about instrumentation. Now I will take you to like how I entered into this field, or I would say how I entered into the embedded field. So, like you, I 10 years before today is actually that I have completed my 10 years of career work experience. So I'm glad that on my 10th anniversary of work. I'm presenting to the students. So it's really honor. And I would like to start my journey from after college. I first job I landed was having National Instruments LabVIEW software work. So I never imagined that um whatever I learned in my college will actually give me work. I never imagined that, but I wanted to do that because I don't wanted to waste whatever I've learned my 4 years of engineering. And luckily, first job itself, I was working on LabVIEW. I hope still LabVIEW is still there in our curriculum. So don't underestimate that software. It has a immense potential. I work for barcode and image processing application using the LabVIEW, and then the next job I got was on the SCADA and PLC development. Definitely, these are the basic building blocks of our syllabus. Everybody knows it. So don't think that these kind of work is not having any importance in day-to-day life. These are actually really useful things in the industry. You can take any plant, like it can be pharmaceutical or it can be tire manufacturing, it can be tablet manufacturing, it can be anything. Everywhere these things are used. If we go to the next point, like the industrial data communication protocols like Profibus, Modbus, we must have learned about all this protocol, Ethernet and CAN protocol. So we thought why these protocols are there in our curriculum. But but the thing is, these are again like small building blocks, small things play a role in the day-to-day life. You are using your, currently we are connected through internet to the like in this call. That is a good example of how Ethernet protocol is useful in the day-to-day life. So I was also like you same when I was in college, like why this protocol I should learn when I don't want to and land into something. But I wanted to land into embedded system. So I never like after my college I go luckily I had gone through this kind of syllabus, and I had this knowledge which helped me to pursue my further enhancement, or I would say growth in the career in the embedded system. So that subject really helped me, and here only I started actually building the code, understanding the hardware for particular protocol, different layers involved in particular protocol. That actually helped me to change my career from being an instrumentation engineer to the embedded systems. So further on, after this particular application, if we go to the next point, I started working on data loggers and gas detection systems too, which are also a very good example of embedded systems where many hardware and many sensors, like to detect the particular gas, you have various kind of sensors. It can be carbon dioxide, it can be sulfur dioxide, nitrogen, it can be any gas. Each has a different sensors. So trust me, like I had that knowledge of sensors which helped me to understand these systems and how to validate those systems. It was all helpful. Whatever I learned in instrumentation, it was all helpful here. And luckily I entered into the automotive applications in my same past company, where I developed the whole embedded system by my own. Like it can be your cars,
Nishant,
any.
I guess there is some problem with your internet connection.
Oh,
Nishant,
sorry.
sorry to interrupt you. I guess
Okay.
there is some problem from your internet side. Can you
Can you
please
hear
check
me?
it? And yes, yes, I can hear you, but there is some interruption in between.
Okay,
So,
okay.
will you please check the internet?
Yeah, yeah, sure, sure. Just give me a moment. Is it fine now? Can you hear me?
Yeah, Yes, yes. Thank you.
Okay. Yeah, thank you. Yeah, sorry for that. So yeah, so I was talking about the automotive application. So like many complex functionality of the cars are currently on embedded systems. So I got opportunity to work for a sports car in my past company, where I developed these applications, and that luckily totally changed my career from being an instrumentation to the embedded engineer. I also perform the in-vehicle networking of a vehicle. So these things possibly, I mean, these things were possible only because of being an instrumentation engineer. And also there was a self motivation about entering into, working for the latest technology trend, which I could do easily because of my background as an instrumentation engineer. Finally, I landed to work for Volvo Construction Equipments, as you know, like JCB and the road paving machines. So these are highly complex machinery where a lot of complex coding and lot of complex system knowledge is involved. A lot of sensors are involved. So it was really pleasure to work for these kind of where like you have to measure the vibrations, you have to measure the temperature of the particular road, you have to check whether the like road is smooth or having potholes. So there are a lot of sensors involved in these kind of application. Trust me, these no, without this knowledge of instrumentation, I wouldn't have been able to do well for these jobs. And finally I landed currently to work as a technical specialist for Robert Bosch. So here my core work is to work for the like Naveen, if you go to the next point, like radar sensor based autonomous driving. So many of you technological enthusiasts have heard about autonomous driving, like where there is no driver involved in the car. So I am currently working on such technologies. So I mean, 10 years before, I had never imagined that I will work for such technology. But due to my embedded system knowledge and my CAN protocol knowledge and my sensors knowledge, I finally landed a job in Robert Bosch 4 years before. And I am currently working for, like, radar sensor based controlling the entire car. Like your car will actually stop when some object comes in front of it, and also it will adapt to the object which is next to the car. Like for example, the car moving before you is going at 50 km per hour, then your car also will start speeding at 50 km per hour. And if the other car goes 60, then your also will go 60. So such kind of like highly technological work, I never imagined I will be working, but all that was possible because of my whole this journey. And I'm really proud today to work for such technology. And many enhancement are currently going on in autonomous driving also. You must have heard about data science and machine learning things which are very much trending. So these sensors are actually learning the data, actually capturing the data, and there is a brain involved in the car which is actually learning the data. You can say it is learning the infrastructure on the road, it is learning the traffic signals, it is learning how the driver is driving the car. So it is actually learning the pattern or how the driver is driving the car, and taking the decision, informing the driver that please drive correctly. If suppose driver is currently drowsy, it will car itself will give the information to the driver by jerking the steering or giving some alarm that you are drowsy currently. So these are all like advanced data science or AI based system, where sensor gathering, data gathering is really important, and embedded system knowledge is really important. I would say like entire instrumentation plays a role in any system, as I told in the beginning. So it's really important subject overall. Yeah. So I think that's all from my side. Thank you for having me. Over to you, Naveen. Yeah.
Thanks a lot, Nishant. I hope he did. I think he did a great job selling instrumentation to every one of you. So what I'm gonna do now next is I'm gonna deviate a bit. So I'm still gonna talk about one topic you have in your mechatronic system, which is basically the intelligent control and the artificial neural network and basically kind of a machine learning or a data sciences kind of a topic you have there. So I'll be talking a bit about it, but and also one of the reasons I wanted Nishant to talk first or give you guys a overview is to understand what you're learning there. Because this is a very good example of someone coming from instrumentation and actually proving his record there and getting into a job which is actually going to work into autonomous cars. And I think it's pretty cool, and that's why I wanted him to start first. So where I come from, or like who am I? As Nishant said, graduated 2011. It's exactly been 10 years um, since our graduation. So I currently work as a engineer slash machine learning engineer or data scientist at Adobe. And For people who don't know what Adobe is, it's the Photoshop PDF guys. Uh, so what I I actually transitioned from my journey from being an instrumentation engineer to going into a completely different stream. Um, and what I'm going to talk about right now is basically, what is this field about? And because I've heard a lot of hype, people are hearing about these things, and people are generally interested to know. Uh, so I'm going to quickly walk you guys through. I'm not going to do a deep dive session here because that's usually a talk I do by myself. And it takes a whole different hour for that. But what I'm going to do is like quickly walk you guys through how I did, like how instrumentation affected me, or like as I graduated, and from there how I chose careers, and eventually I went into data science. And few things which you learn in instrumentation are actually pretty good to carry forward yourself into a stream like data science or data engineering or machine learning engineering. Uh, Going ahead. So yeah, also one thing I would like to ask from you guys is if you like any slides, if you don't like any slides, if you have any questions, pop it
Naveen,
up in the chat
sorry to
itself.
interrupt you.
Sorry, yeah.
Naveen, sorry. Having some internet glitch in between. Just check your internet. I'm so sorry.
Okay, sure. Do you want? I'm not really sure, but let's just.
Otherwise, if it is okay, you can carry on.
It seems fine. Cool. Okay. Yeah, I'm going to go ahead then. So the one thing I would like to ask is if you guys have any feedback on any slides, or you like or dislike any slides, I would really appreciate you guys commenting right away. If you find something funny, not funny, anything, just feel free to just comment it and let me know. That'll be really helpful for me as a feedback. Um, so let's start. So what is data engineering? What is data science, right? So there's a ton of hype about like all these things, and you guys have a certain topics about artificial neural networks, neurons, fuzzy logic and stuff like that. So those things are the concepts what most of the data scientists use, and those have like a lot of statistical importance when you talk about neurons or neural networks, right? That's completely a deep learning sector, which I'll eventually get to. But to take a step back from there, and if you take this course, of course, obviously you're learning that. It will be great if you know these things or terminologies. But again, I also want to would you guys to be realistic. You won't be learning everything in detail. And I'll be walking you through why or what detail means, or what is the industry standard or expectation of your, expectation from you to have a certain level of knowledge. Uh, so in data science or engineering, most of the stuff we do first is cleaning of data and knowing and learning, understanding how data flows and works, and trying to understand SQL and just writing basic queries. So yeah, most of the 90 to 80 to 90% of the work, what I'm trying to do in data science or data engineering is basically I'm joining data, pushing data into tables, into databases, and trying to join data and make sense of it. Uh, and the bigger joins and the larger data sets you work on, the better engineer you become, because those are the challenges you face. So if you talk to someone from an engineer from Facebook, Google, Apple, right? These people work on massive data sets. So to learn how to use this data, to manipulate this data and like clean this data is one of the biggest challenges and one of the first or one of the most I would say heavy work you need to do as a data scientist or a data engineer there. Again, I'm not going to go into detail into everything of this session, but I'm just going to quickly walk you guys through over like what do you guys the skills required, what are pipelines, tools, who people interact with, and just generic of what are the differences of a data engineer and a scientist. So this is usually a whole skill sets or section of skills that you need to be a qualified like a decent data engineer or a scientist. It includes data modeling, automation, ETL development, good statistics, and good API development. I know this is a lot to ask, but I'm just going to quickly give you a glimpse of what these things are. Data modeling is basically just trying to make sense of the data. If you have Facebook data, if you have like Instagram data, like if all these data, all the click streams are happening, you like a video, you like a comment, write a comment on these things. This data goes somewhere and it is modeled in a way that you can query it and you can extract valuable information for it. And that's what modeling is. So it's one of the most basic tasks you learn as a data scientist or as a data engineer. And you basically build your business model around it. So one of the examples here is, it's a very easy product of a company with its sales and business specifications or transaction specifications. So this is how usually a data modeling concept looks like. Again, this is a whole subject of its own. I can't go in deep. So the next is automation. You basically what you need to learn is once you've made a model, you need to learn how to automate things. You need to learn how to automate data pipelines. You need to learn how to automate models to start up and run and create predictions and things like that. You can't like sit and have things manual. So that's also a sector you need to enhance your skills and learn different kinds of tools in it. Celery or cron is one of the kind of tools you need to learn. Again, these are the things you don't really learn in school. This is something the skill sets you eventually will learn. And don't get discouraged that like when I'm showing you these things, what I'm trying to say is that you don't know things. What I'm trying to say is that these are the things you eventually should focus on learning if you are trying to get a job in a in a data science or a data engineering sector or a machine learning sector. ETL development is a very big part of this thing too. It basically talks about taking data from one source, pushing it as a source in a more clean manner. Most of the data you get is never clean, and this is the most boring work. Or this basically is what takes a ton of time to. So learning how to optimize these things, learning how to build good ETL pipelines, it's a skill set on its own. It's a job on its own. So this is also one of the most, I would say, lucrative skills to have, and very one of the most highest paid jobs you get. So definitely it's something I would recommend checking it out. You need to have a great understanding of product, what you're trying to build, how you're trying to build, and that's where your communication skills come into picture. Because as a data scientist or a data engineer, right, you're not most of the time people don't know what they want. So you have to work with people. And what I mean with that is that you need to learn how to talk technical aspects with non-technical people, and it starts in college, honestly. When you're having communications like classes or these things, right? Try to ask yourself these questions: can you do these things, right? Because that's what a good communicator is. And again, one thing I want to point out is that language should not be a barrier. You should not English is not like you don't need to have a fluent English when I'm being communication. I have a lot of colleagues here. I live in New York, so I have a lot of colleagues who come from China, who come from Japan, or other South American countries. Their English is not good. They're legitimately very good coders, and they have very good communication skills and describe problems in very simple English. So that's something I would suggest you guys to like start thinking from now and understand like how you are in communication. Um, I'll actually skip the slides. Maybe too much for you guys. Learning how to optimize uh, jobs or your code. It's one of the most crucial factors of big data or data science or data engineering in general. And I'll tell you an experience of my own. I actually wrote a bad line of code once, and that actually burned $40,000 of compute for Adobe because I didn't optimize my code. And what I'm trying to mean here is it's basically learning how like good tools and technologies in the particular field and being passionate about it. That's one thing you need to be in this field to understand which technologies, which frameworks to pick. And this might be too much of information for you guys, but that's, I would say, in a short way I can put. Uh, Coming to this point, this is a question I'm asked all the time. So it's basically what is the hottest technology, what is the most appreciated technology and stuff like that. Now, if you want to start learning about data science, if you start want learning about data engineering and the scope of data science happening, how do you approach it, right? So go for most of the people in data science love Python, even in data engineering. Scala is a great language to have. Java is actually not that popular. TensorFlow is basically the framework where you use to build neural networks, and most of the companies still use Excel. So just to give you a sense of like what's happening out there. So I've just walked you through quickly through what data science is, and what data engineering is and what it contains. But why do go in this field? Like, तुम लोग जो भी कर रहे हो, why do you want to go into it? Eventually, you want to get a job so that you get a decent salary, you get a decent, pay. And it can be anything. It can be embedded systems, or data science or anything. So first, I'll actually call up Nishant again, just to give you guys a sense of what's the industry about. So Nishant, what do you think is like if someone is graduating as like someone is graduating instrumentation engineering now, what do you and he eventually wants to become an embedded system engineer? What do you think are the career perspectives, the job perspectives, or the salary perspectives of that kind of a person going to today's market?
Yeah, so like if you enter into this as an embedded domain or embedded profile, as Naveen has mentioned on the screen, like parle ji khana pad raha hai. I mean, it's not literally parle ji khana pad raha hai, but it's like every student or every small child, as a small child, we had a dream that अपना एक बंगला हो, एक गाड़ी हो, foreign trip मारनी है. So such kind of things, like if you want to achieve, you need to be smart first of all, like to choose your profile, if you have such kind of dreams.
So
uh,
Nishant,
yeah,
I'll ask you, I'll put this in a different way. So
yeah,
what kind of salaries do usually embedded engineers start? They're starting, right? Or like
yeah,
what's the range of it, if you're getting a job in anywhere in
yeah,
India in a
yeah, right.
mid-tier company?
Yeah, so like if you are like in the mid-tier company, and if you have 5 years of experience, you can
let's
just
let's
multi.
talk about let's talk about like how you start, and so, like not even talk, because that's what they're here for. Like
Yeah,
they
yeah,
are third year kids and they're going to graduate next year, right? So what do
yeah,
you
yeah,
think is going to be like if someone is really passionate about it
yeah,
and wants to give it a shot? Like मेरे टाइम मेरे को पता भी नहीं था कि किसको ये सवाल पूछूं मैं. Okay,
yeah,
right? कि अगर मैंने like मैंने पूरा दम लगा दिया embedded systems में, like I wanted to become an embedded system engineer, right? I don't know, but if I divide the field in three categories, like mid tier हो गया, average, sorry, low mid, or top tier. What would be the salary ranges of an embedded engineer joining these companies?
yeah. So if you start with like small firm, you will be hardly getting like 3 lakhs per annum as a starting job.
Okay,
Yeah,
okay,
and if you are going in some high, you can say some very big company, like for example Bosch, like then it will be like around 5 to 6 lakh the starting job.
okay,
But if,
got
if
it,
you go to some like semiconductor company like Qualcomm or Broadcom, something like that, there you
okay,
might get some 8 to 9 lakhs as a starting job. Yeah,
got it.
but
Just still good. Okay,
yeah, but getting into these companies directly, like via off campus, is not at all easy. You have
Okay,
yeah, on campus definitely. They come to the some of the colleges, not every colleges they go.
okay,
These big companies, or maybe they go to some private institutions where the embedded courses are going on.
okay.
But yeah, otherwise, you have to start with a small firm. So initially, as I told, it will be very struggling days, or I would say very few, very less salary, I would say.
Got it.
But
But
yeah,
let's not talk about what you mentioned, right? Like what
hmm,
happens after you are like you do really well. Like for example,
yeah,
your experience. You started with a small, very company, right?
yeah,
And then you moved your way up to like good companies, right?
yeah,
So and you struggle hard. You
yeah,
had no our stream. The stream was not very developed, and you had
yes,
to like make your own way through it.
yes,
So after working for a lot of people, I know 3 to 5 lakhs is not very lucrative as starting.
yeah,
I've
yeah,
heard that too, and makes sense because expenses have increased. That might not be lucrative right now.
yeah.
But if you do well and if you perform well, right? What are the opportunities in 5 to 10 years, right? What can you be looking at, or what can you be targeting at?
Yeah, I mean, if you like down the line 5 years, if work really hard, you can go within 5 years. You can go up to 20 lakhs or more than 20
Oh,
lakhs.
nice.
Yeah,
So like going and
yeah,
like if you move to a top tier company, just in
yeah,
India itself, you can go from
yeah,
20 to 50 lakhs
yes,
range, right? Depending on
yeah.
the company you're trying to land.
Company,
Oh,
and
that's
yeah, how much work you do, like what quality kind of work you do. That all depends. How much knowledge you
got
have
it.
for that particular field. Yeah,
Makes sense. Uh,
yeah,
so, uh, so before ending, I would like to share my journey. Like I wanted Nishant to speak first because he gives you a very good aspect of embedded systems, and I'd like to share a different journey of mine, which is not exactly instrumentation, but it might help you to get a sense of what I have done or like where I am right now, and what you need to do if you want to like reach my base. So the way I started was like I was pretty like I wouldn't say it's a reckless is the word. मेरे में ओवर कॉन्फिडेंस और ईगो बहुत ज्यादा था. So third year I was like मेरे को एप्पल में जॉब चाहिए इंस्ट्रूमेंटेशन से. मेरा मेरा पर्सपेक्टिव ही ऐसा था कि नहीं मैं करूंगा वो कि मुझे वो करना है. Okay, and it doesn't have to be for all you. I'm just sharing my journey, but like that's the approach I had towards life then. And I that time I never heard anyone doing it. Like I never heard any instrumentation engineer completely changing the profiles. Heard them going to public companies like Gale or I have friends who are doing well in Middle East and oil companies. But I didn't hear about this. Um and I was stupid, honestly. I was very stupid during those times. But I had that passion. So what I did was I finished my undergrad and then I joined CDAC. It's a embedded systems diploma course, which the government has actually. CDAC is an institute which does research for DRDO and everything. They have a course which teaches embedded systems. So it's actually pretty difficult to get in, and I highly recommend that to check them out. So it's a 6 months course you do. They basically teach like a whole 2 years masters in 6 months. I got into it. I got into that. I finally landed from there. I landed an embedded systems job. That was my passion. I was like embedded engineer ban ke rahega main. And that's how I was approaching it. And I finally became an embedded system engineer. And I got into Rockwell Collins, which is an aerospace firm. And during that time, I cracked like a 5 lakh job. Starting salary था मेरा तब. And this is back in 2012, which is supposed to be a dream salary then. So I have a bit different story than Kaku. So I thought I landed my dream job, uh, but I hated it after a year. I was like, मेरे को embedded systems करना था, but I didn't have the similar passion as Kaku. मेरे को उतना मजा नहीं आ रहा था उसमें. So after 1 or 2 years, what happened is like I left that and I eventually did my masters. And I got into University of Arizona. I went there. I was actually still thinking of continuing embedded systems, but then there was a requirement, like one of the labs that they needed some, research on big data and Hadoop. And I had done few courses back in Hyderabad on that. So somehow I got into that. I got a research internship there, and I started learning Hadoop a bit more and big data a bit more, which is pretty new back still in 2012. From there, I went to a hackathon. It was the first ever hackathon in Arizona happening. I won a hacking challenge there. From there, I landed an internship, and after landing an internship, from there I landed a job in New York, which was with KPMG. I finally got a job as a big data engineer, and slowly I've worked my way from there, being a big data engineering consultant, eventually to Adobe. And Adobe is where it all started happening for me, because I was finally rubbing shoulders with like one of the best tech talent, one of the best coders, one of the best research scientists. And then I was basically working with people who are extremely smart, like with huge data sets and complex problems. So I finally got an opportunity there to really push myself more. And and from there, finally, what's happened now is that I last week I actually got a job from Apple for the applied machine learning team. But मेरा ego ये है कि मैं उनको join नहीं करना. I'm going somewhere else. But what I'm trying to tell you guys from this experience is that if there is someone there right now thinking that you want to go somewhere and achieve a job which is FANG level or Facebook, Apple, Google level, uh, you people can do it, because I exactly sat where you people are sitting, and I eventually made my way through there. And this is also a reason why you should target these companies, and not say and it doesn't have to be data science. It can be from embedded systems. It can be through product or something. You need to figure out what you want to do in your life and be passionate about it. That's the first thing I would say. Uh, but the reason I tell is, like, you guys are engineers now. You guys are gonna graduate as engineers. The one thing I would recommend is try to work with people who are best in in the industries, and that will take out the best in you. I went from someone who didn't know anything about data science or data engineering to become a technical speaker for one of the biggest databases and clouds. This year, I'm going to be talking with Amazon for their AWS conference in Las Vegas. So what I'm trying to tell you guys here is that you're choosing here and you're here, you're studying these things. Don't be demotivated if you want to choose a certain career or a certain path. And if you like really put yourself on it and do things, instrumentation is actually not a bad place to start. You have enough subjects and enough different disciplines to have the basic knowledge to kickstart and excel in it. So yeah, that's how I'd like to conclude. If you guys have any questions, yeah, I would like to really open it up for questions right now.
Students, if you have any question, you can turn on the mic and ask, or you can type it in the chat box, whichever you are comfortable with.
एक भी क्वेश्चन नहीं, किसी को कुछ पसंद नहीं आएगा?
They all must be absorbing.
I hope so. I'm not keeping.
Yeah.
And again, like, I've already so the thing with this talk, right? I usually give talks on like data engineering or data science or embedded systems itself, right? These are all talks which will like take an hour itself. So try to consolidate as much as you can and feed you guys. So if you guys want to really learn about this or want a detail, I would really recommend talking to your professors and or talking to me, reaching out to me, and we'll try to do a session on it. And I've compressed a lot of information. I'm sorry about that. Like, this is not usually how I do it. But definitely, if you have more questions on these things, or you need a more detailed talk on a particular topic, right? I would highly first recommend to have that, because it will give you a lot of perspective. But yeah, just feel free to put any questions, even if it's stupid or funny or anything. Or if you didn't like my color of my shirt or my hairstyle, that's cool too. Like, अरे कुछ तो बोलो यार, at least लगे कि ऐसा तुम लोग present हो.
हम लोग को कोई पूछने वाला नहीं था तभी, तो आप पूछ सकते हो अभी.
So cool. Good question actually. Data science and data analytics,
Yeah,
right?
there is one question to you. Which is better, data science or data analyst?
So data analyst is doing okay. So data science, right? The thing with data science is that it's actually a very I it's a there's a lot of misinformation about data science. The data science I work with, the research scientist I work with, right now I'm not a data scientist. I'm a machine learning engineer who has the skills of data science and data engineering. Um, but I work with research scientists or data scientists in my team, and they're senior research engineers who have a vast knowledge about statistics. Okay, and people don't mention that at all, which like really bothers me. Or they have PhDs in computer sciences with applied statistics. So there's a huge learning curve of math and statistics you need to do to become a data scientist. And if you want to become a data scientist of a company like Facebook, Google, Amazon, and like these places, you need that kind of educational background too. They cannot get you in on a bachelor's degree with the computer science or instrumentation or anything. You need to like up your education skills for that, adding something like a PhD or a master's, at least a master's. And the reason is there is that my research scientist, he probably makes $500,000 a year. Okay, so first, it's not easy to make that kind of money. Second, you need to have that kind of education because that kind of education justifies that money, if that makes sense. Data analytics on the other side, right, is not need, they don't need that kind of math skills, right? You need basic SQL skills or some programming skills like Python, and then you can start applying for those kind of jobs as a data analyst role. Okay, and that is again, it won't be that lucrative as data science is. So I don't know what better is a very relative word. So yeah, I'll put that for your comparison. You can choose what's better for you from that. Like next,
Uh, Next
we can
is, yeah,
land
please.
a job in mechatronics while doing data science. That's exactly what I'm trying to say. तेरे time तो mechatronics का course है, मेरे time वो भी नहीं था. So my point is, if you really want to do it, you can do it. You need to figure out where you are first with your skill sets in terms of your math skill sets, your statistics skill sets, and your computer science skill sets, and try to start understanding and narrowing that gap. If you are that interested, you can't land a job directly from. You can if you're a genius. Okay, you can just read all like 20, 30 books of data science and land it. But that's very rare case. You probably will eventually like need a PhD or a master's course in statistics or in in computer science with data science as a specialization or applied math as a specialization. Okay, and one of the best institutes in India for statistics is Indian Institute of Statistics in Calcutta. That's where actually my research scientist has done her bachelor's and master's from. Okay, so people actually in India don't give a lot of value to statistics and math. But yeah, that's how you really get into a very good job in data science. If that answers your question. Can we get a job in data science? You have no previous work experience as a fresher. Again, right? You might. Where are you like as a with just bachelors in instrumentation? You're trying to go out and apply for data science jobs. You probably won't get it because you need to try to understand what's the competition, right? Like when you're applying for a job, like a lot of people like ask me for referrals on LinkedIn, and they ask me like, can I get a job or not? And my question is, and okay, this is also one session I do, how to interview and how to apply for jobs. Ask for your professors to do that kind of session because that's a whole session on its own. But to answer your question, you probably won't get a call because first, what is the competition? तेरे ऐसे लोग हैं at least like yeah 10 से 12 लाख लोग होंगे ठीक है and everyone has a computer science degree ठीक है उसके ऊपर होंगे लोग with data science skills or work experiences who will be applying to those jobs. So why will your resume be selected, right? Above those. So that's always the question you need to ask. Why will my resume as a fresher will get selected to that? It will get selected if you sit and maybe Amazon AWS or Amazon hosts these deep racer का एक tournament होता है where they give you a model of a car, and that car has camera vision sensors on it, and you need to run it in autonomous mode. Sub free है, sub SDK is available है इसका. Do that, get a good ranking, put that on your resume. I bet people will hire you for as a data science engineer. Just looking at that, you'll go basically learn how to do reinforcement learning and apply models in it. You can do everything is there online. You can learn everything and put it and start competing there. So you need those kind of things on your resume and build your resume in that manner so that you can compete with the competition. If that answers. Sorry if the answer was long. If that answers your question. What course can we do for MS? You can do anything for MS. You can do computer science, you can do MBA, you can do anything. And that's the beauty of it. Like you're not restricted to instrumentation anymore. Or if you want to do instrumentation, go for it. There's nothing wrong in it. But what I'm trying to say is that you want to do masters in data science itself, go apply for masters in data science and start doing it. Yes, you obviously are not gonna get into Harvard or Stanford or all those places. You might have to create a work experience in India, eventually build a profile, and then get it. But even if you want to do a direct master's course, you'll probably get it in some university, and that's not something I will recommend. If if you want to really do MS, first figure out if you like the field or not, and you're cut out for it in India or not. Because once you come to US, your competition is not India, it's the world. Okay, and the world is competitive. China से आएंगे coders, Japan, France, फाड़ देंगे. First, try to see if you're fit to fight in India and land a job there. If that answers your question. Yeah. Thank you. Abhishek ने तो बोला अच्छा. So, do online courses about data science and embedded systems from Coursera or Udemy considered while looking for a job? Uh, okay, the courses are not considered. The projects are considered. Okay. Whenever you need to realize and understand, right? अगर मैं interviewer हूँ और मैं तेरा resume किसी और के साथ compare कर रहा हूँ. So, for example, you're Shraddha. Sorry if I'm saying your name wrong. And above there is Ragini Nair. You both have your resumes, and I have both the resumes in front of me, right? So, if you have done courses and you have made projects and have listed them in your resume, and that's all I can actually expect from you as a fresher, right? Because you have honestly gone out of your way, went to a Udemy course, learned it, and implemented and put that project in your resume. That beats someone who has not only put percentages in their resume. And that's what I did when I was in college. And I did that mistake. So what I'm trying to tell you here is, if you're learning those courses, it's great because it'll first give you a sense of what that field is. Second, it'll give you an edge on anyone who doesn't have that kind of experience to applying for companies like startups because they don't need a lot of experience. If you've done a course or two, if you build a project or two, they might pay you less, but they'll give you a kickstart. Okay. And this is actually a story from me and Kaku both. We didn't get great jobs. We worked for pennies, we worked for very minimum salaries. We got a kickstart in the field we love and eventually made our progress there. So yes, that is a route you have. And to give you a reality check, right? Yes, we said is not a top college, right? I'm not cursing you guys or anything. It's just a reality check. You guys are not IITs. You guys are not VJTIs either. VJTI long कोई नहीं मिलता actually. But you're not IITs and NITs. But if you want to land those jobs, you need to have a resume of an IIT or an NIT. Does that make sense? So you need to learn things to compete with people who are already above you, because you'll be competing for the same jobs. Yeah, that's all. I'll put that for the answer.
Anyone else?
Sorry if my answers are too long. Just tell me to cut short.
No. Anyone else have any questions or a feedback to give in a chat box? Please feel free to give that.
Okay, thanks.
ओहो, मेरे लेक्चर में कभी आग नहीं लगती पीयूष. Okay, really wonderful. Thank you, Naveen, and thank you, Nishant. It was really a wonderful session, and you actually helped them to choose the career path correct career path. And thank you very much for giving me the prompt response, Naveen and Nishant both.